Okay, welcome back. Math 200. We're taking a look at 6.2, part 2. Part 2. So we're adding up fractions with unlike denominators. Not easy. So we need to find the LCD between 7a and 6a. The long way to do that is you bust it into its primes, and then we take anything they have in common. Both have an a, so take that, and then you take all the leftovers. So 2 times 3 times 7, those are all leftovers. So we got 6 times 7 is 42a. So put that on the bottom, 42a, and now we work backwards. We kind of say, okay, I want 42a on the bottom. I got 7a, so I multiply that by 6, I multiply that by 6, 30, 90, and we multiply that by 7, 7, and so there we're looking at 56. And now we add up the numerators, we leave the denominator the same, so we got 42a on the bottom. On the top we got 146, and oh no, we can reduce that, divide by 2, I think, 73 over 21a. And that's our answer. Weird answer. Okay, this one, just again, you know they're up to shenanigans when they reverse it like that. So let's write it the other way around. So we have this as 5, 2x minus 6. Leave the minus there, negative 2x plus 6 over 3. And now think of it this way. If I multiply the top and the bottom by negative 1, that's okay, because I'm doing the same thing to both top and bottom. So this I'm going to rewrite, that's the same, 5 over 2x minus 6. But this is now minus a negative 3, so that's a plus 3 on the top. And I distribute the negative across the bottom. And voila, like terms, like bases rather. So we can, not bases. Common denominator, sorry, this has been a long day. 2 divided by 2, x minus 3. And so that's what's on the bottom. The top we have 5 plus 3 is 8. And then we can reduce it. 2 goes into 8 4 times. So 4 over x minus 3 is our final answer for that one. This one, we say it's over 1, and then we multiply top and bottom by 2x minus 3, 3. And so here we have 7 over 2x minus 3. Here we have, what is that, negative. We'll make it a plus, a negative, and then distribute the negative. So negative 6x plus 9, 2x minus 3. And so what that goes into then is 2x minus 3 on the bottom, and negative 6x, 7, and 9 is 16. And there we go. All right, so let's look at the next page. For 6.2. So we have 4 over x squared minus x minus 6 plus x over x squared plus 5x plus 6. Oh boy. So let's factor that. X squared minus minus x minus 6 multiplies to be negative 6. So suspects for negative 6. Negative 3, positive 2 is negative 1 when you add them together. So that's what we want, x minus 3x plus 2. And then this one, x squared plus 5x plus 6 is equal to 2 and 3, right? X plus 3 and x plus 2. Positive 3 times positive 2 is positive 6, and 3x plus 2x is 5x. All right, so then when we want the LCD, we take what they have in common. So this is common. Put that down once. And then we take all the leftovers. So those are both leftovers, x minus 3x plus 3. So do yourself a favor when you're doing these problems. Add this extra step. I know it's more writing. I know you don't like to do more writing. I don't like to do more writing either. But it's a lot easier. We already factored it here. Write it in factored form before you write down the LCD. And then we get to play Sesame Street. One of these things is not like the other. So look. We want this x minus 3, x plus 3, x plus 2 on the bottom, each one of these. X plus 3, x plus 2. So we work backwards. Again, we look at this and say, what's missing from here to there? What's different? One of these things is not like the other. So this one is the same, this one is the same. This is missing. I need this one to be in my LCD, but it's not there. So I'm going to throw that in as x plus 3, but I have to multiply top and bottom by that. And do the distributive property. So 4x plus 12 up there. This one, what's missing? We have x plus 3, we have x plus 2. We're missing x minus 3. X minus 3, that's x squared minus 3x. And now we're going to add up the like terms on the top. And I don't think that's going to work out to be factorable. X squared, we have plus 4x and minus 3x. So that's plus 1x plus 12 all over x minus 3, x plus 3, x plus 2. I think that is it. Multiplies to be 12, 4 and 3, 6 and 2, 12 and 1. None of those will add up to 1. So that is all she wrote. That is the answer. All right. Number 5 looks like this. So number 5, we're looking at 2x minus 1 and 2x squared minus 9x minus 5 plus x plus 3, 6x squared minus x minus 2. All right, so, oh boy. This one's going to be a little on the ugly side because we have to do factor by grouping. So AC method, 2 times negative 5 is negative 10. Suspects for negative 10 are negative 1 and 10, negative 10 and 1, negative 2 and 5, negative 5 and 2. We want negative 10 and 1. So we're going to sneak in a negative 10x plus 1x right there. We're going to leave the minus 5. We're going to leave the 2x squared. All right. Here, we're going to take 6 times negative 2. That's going to be negative 12. And suspects for that, negative 4 and 3, negative 3 and 4. Oh, right there. Negative 4 and 3. Negative 4x plus 3x. Where that x used to be, negative x. And we leave the minus 2, and we leave the 6x squared. All right, so let's factor this. We can factor out 2x, and we we get x minus 5. We can factor out a 1, get x minus 5. And so x minus 5 times 2x plus 1 is factored form of this. So let's rewrite it. So we have 2x minus 1 on the top, and we have x minus 5, 2x plus 1 on the bottom. The other one, we got to do the same way. We'll pull out a 2x, and we get 3x minus 2. We pull out a 1, and we get 3x minus 2. And so it's 3x minus 2 times 2x plus 1. So we have this one as plus x plus 3, 3x minus 2, x plus 1. All right, so we have a 2x plus 1 in common, and then those are leftovers. So if we do the LCD, we take what they have in common, and then we take all the leftovers. So x minus 5 is a leftover, and 3x minus 2 is a leftover. So that is my LCD. So I want this to be 2x plus 1, x minus 5, 3x minus 2. 2x plus 1, x minus 5, 3x minus 2. So when we take a look at what's missing, so we have that. We have that. We don't have this. That's what's missing. So that's what I have to multiply top and bottom by. And so now that is going to be 6x squared minus 4x minus 3x plus 2. This one, what's missing? We're missing an x minus 5. X minus 5. So x squared minus 5x plus 3x minus 15. We add up those like terms on the top, and hopefully we won't be able to factor anything else. 3x minus 2. So 6x squared plus 1x squared, that's 7x squared. Negative 7 and negative 2 is negative 9x. That was negative 4, negative 3, negative 5, and positive 3. So basically those 3's wiped each other out. Negative 4 and negative 5 is negative 9. And then 2 and negative 15 is negative 13. Whew. That was a tough problem. All right, and the last one on 6.2 looks like this. So the upside of having this on YouTube, I just erased it, but you can always just pull that little thing back and freeze it and take a look at it. And so if there's an upside to all of this, maybe that's the upside. X squared minus 1, and oops, minus 5, minus 5. Minus 5 over x plus 1. So we're looking at x squared minus 1 is x plus 1, x minus 1. And this is already just x plus 1. And that is already just x minus 1. So when we find the LCD with like 3 things like this, what we do is we take anything that is common. So that counts as common, x minus 1. This counts as common, x plus 1. And then all the leftovers, but there are no leftovers. Everybody was spoken for. So let's rewrite it. Put that guy in parentheses. X plus 1, x minus 1. 10x minus 5. X plus 1. And let's rewrite this just so we don't make any mistakes here. It's been a long day, plus a negative. So there's a negative on the 5, just so we don't forget. So we want this, this, and this to have this as my LCD. And so now you work back. And you say, okay, this one's missing an x plus 1, so 7x plus 7 up there. This one's missing nothing. It's got the x minus 1, it's got the x plus 1, so that just gets to stay 10x. And this one's missing the x minus 1. So that becomes negative 5x plus 5. And now we just combine the numerators. We have a common denominator now, x minus 1, x plus 1. And so the numerator, 7x plus 10x is 17 minus 5x is 12x. And plus 7 and plus 5 is plus 12. Oh no! We can factor the top. Let's factor out a 12. And if I divide that both by 12, we get x plus 1. And now look at what we can do. X minus 1, x plus 1. We can actually cancel those x plus 1s. Whew. These are some tedious problems. 12 over x minus 1 is my final answer. You can put parentheses around it if you want. You do not have to. And that is all for 6.2 Part 2.